Hi everyone, welcome to our first tutorial class for KOT122 Organic Chemistry 1. I'm your tutor, Mr. Tan. So before I start, let's just see our tutor submissions format. So for your tutorial, please make sure you write down your full name, your metric numbers, the titles of the tutorial, and of course, just straightforward write your answer without copying the questions. So I have set up the platforms for all the views. For group 12 or group 14, this is my group classes. So I already set up the columns where there's one side is submit the questions and another one is an exercise. Please make sure all of you submit both at the same time. And when you submit your tutorials, make sure in the column write out your full names and your metric numbers. And of course, for your file, make sure you label it clearly whether which one is submitted questions and which one is the exercise, followed by your group and your full name for the file. So for tutorial submission, make sure you double check your answers and all the pages, please make sure in the portrait layout. Please don't give me a snap where there's a landscape in the halfway or just inverted. Please double check all of it so that I can do my evaluation smoothly. And of course, just answer, keep your time for your revisions instead of wasting time on copy questions. And if can, write down the step beside your answer to aid your revision. So after when you see my tutorial videos, please make sure you write down steps beside your answer. Remember me. So without further ado, let's start for our first questions. This is chapter 1, questions 47. It's require you guys to draw isomers for C3H7Cls. So when you draw the isomers, please make sure first step, assign non-single bond atoms towards skeleton structures. For example, C and O, S, etc. There's those atoms that can bound more than 2 bonds. So in this case, we got 3 carbons atoms, so we just align 3 in a straight. So after that, we fill in the single bonded atoms such as hydrogens, halogen, like chlorine, bromine, fluorine, iodine, etc. So after you have assigned all the single bond atom, just double check the octet rule and fill in the double bonds. Same rules goes to the other questions, which require you to draw 4 isomers for C3H9N. So in these questions, we see there's a carbons and nitrogen, which means there are 4 atoms that can align in 4 different formations. So in this case, we can see there's 2 aliphatics and 2 branches, skeleton structures. So after that, we just fill in the single bond atoms and check the octet rules to fill in everything. So here's the answer for the 4 isomers. Next is questions 49. This is a questions where they want you to find whether which one is the isomers and which one is the resonance structures for A. So when you encounter this kind of questions, please make sure you find out which one is the resonance structure first. So in this case, make sure the resonance structures is abide to 3 rules. One is same atom and single bond placement, and different in multiple bonds and non-bonded electron. Second rules, same unpaired electrons, and third, valid Lewis structures. So when you see A it can become E after the transformations. Same goes to the C. So for these three structures is really abide to the three rules. Wow, the B and D, there's a different in the what we call the atom placement. For example, when you see B and D, for the green circles, there's a one extra hydrogen atom. Wow, another side has less hydrogen atoms there. So which means D and B is not the resonance structures for the compound A and is considered an isomers. Same goes to questions B. It's required us to find out whether which one is the valid resonance structure of A. So we have to show it how it works. So when you draw the leaf structure for the arrow, please make sure the way the arrow pointed is in the specific places, whether you want to point to the bond or point to the atoms. So for resonance structure A, it can become B or E, which is abide to the three rules of resonance structures. Wow, C and D is not the resonance structure because first, C there's not the same atom placement, while D will share the same traits where there's extra two hydrogens in the structures D. Next is questions 58. Which of the given resonance structures A, B, C contribute most to the resonance hybrid and which contribute least? So back to basics. For the stable resonance structures, there are less charges and more bonds. So in this case, we analyze all the A, B, C structure based on the charge and the bonds. So as we can see, for structure A, there's no charges and 3 CO bonds. Structure B got 2 charges and 2 CO bonds, while C got 2 charges and 3 CO bonds. In this case, we can see that A has a less charge and the most bond. So which means A structure contribute most to the resonance hybrid. So we just left B and C to analyze whether which one is the least contributed, which means we have to find whether which one has a less bond. In this case, B has a less bond compared to C, so B contribute least in the resonance hybrid. It's very simple. Question 61. Predict the geometry around each highlighted atom. So to determine molecule shapes, we have to ignore the molecule bonds, multiple bonds, which is considered one group. So for B, there's considered 4 groups, D 3 groups, and E got 4 groups. So for B, it's predicted tetrahedral, but since there's 2 lone pairs, it's a band shape. D has 3 groups, but since there's no lone pair, it considered same as the predicted, which is a trigonal planar. E, there's a 4 group, which predicted tetrahedrous in shape, but since there's one lone pair, it actually is a trigonal pyramid or the triangle pyramids. For question 77, octocrylins. It wants us to find another 2 additional resonance structures. So here's the resonance structure that in the most possible way. So for the right side, I already put some extra info for the resonance structure common cases. Either you want to learn it by yourself or just ignore it. It's okay. It doesn't matter. Just learn it based on your own pace. Don't be stressed about it. So for the other resonance structure, it's is acceptable as long as it abides to the 3 rules that I mentioned before. So for the E, it requires us to find which is the polar bonds. So very obvious, there are 4 polar bonds in total, 3 CO bonds and 1 CN bonds. So how to determine polar bonds? Yes, this is a bond between 2 atoms with different electronegativities. It's kind of simple as that. So we proceed to chapter 2, questions 42. So it requires to find out the reactions between the Boston lauric acid and Boston's lauric base. So when you encounter this kind of question, please make sure you find out which one is the Boston lauric acid. So when you see there's an acid for the proton, so make sure you find the lone pair from the base. And your arrows must be started from the lone pair of base, go to attack the proton, while the rest of the electron from the bonding will go back to the adjacent atom to form the conjugated base. So the same concept goes to the questions 43. First, identify which one is the Boston's lauric acid. After that, make the lone pairs of the base attack the protons. And we got the answers. It's a pretty straightforward reactions. It's considered a proton transfer process. So for chapter 2, questions 44 is asking whether what will be to the chemicals if we undergo reaction with sodium hydride. So for your information, sodium hydride is a very strong base, which is a proton acceptor. So for this question, you just identify which is the site where the NaH will go to attack with. So pretty straightforward. You just eliminate the H and the remaining electron go back to the adjacent atom. Pretty straightforward. For questions 53, it requires us to do the ranking based on the acidity strength. So as we can see, there's 4 factors affect the acidity. 1, elementary effect, 2, inductive effect, 3, resonant effect, and the last, hybridization effect. So in these questions, we can see there's different elements that causes to the proton. So we just do this first screening, which is the elements effect. So we can see A there's OH, B CH, C NH, and D OH. So we can do the first screening, which is CH, the weakest acid, next NH. Wow, the remaining answer for A and D is OH. They share the same element effect. So how to do? We proceed to the next screening, which is inductive effect. So for the inductive effect, we can see there's a bromine atom there that induce the whole structure, will make it become a stronger acid. So A will stronger to D. So we can do the ranking where B, C, D, and the stronger acid is A. So they want us to find the strongest base, so we just find the weakest acid. As simple as that. Next, question 55. The pK values for 2 ammonium cations drawn below are 8.33 and 11.1. Which pKa responding to which cation? Expand your choice. So back to our 4 factors: element effects, inductive effect, resonant effect, and hybridization effect. So based on the structures, we can know they share the same element effect, which is an NH. So how we select it? Based on the second effect, inductive effect. So as we can see, there's an oxygen atom in the second structures. So we can know that more electronegative atoms stabilize the conjugated base by electron withdrawing inductive effect. makes the acid stronger. Hence, oxygen atom increases the strength of acidity. So the right side structure must be the lowest value in the pKa, which is 8.33, while the left side is 11.1. So if you scared you're confusing with the acidity strength, so make sure you can recall that when the pH is lower, the stronger the acid. Next, chapter 2, question 66. Bupivacaine is a quick-acting anesthetic often used during labors or delivery. Which nitrogen atom in bupivacaine is more basic? Explain your reason. So we refer to the 4 factors, and now we focus on the third effect, which is a resonance effect. So when you see the ends, the left side NH, the lone pair for the N will localize based on the resonance, make it less available to donate to acid, less basic. While the right side is the lone pair is located on N, make it more basic. It's very straightforward. So we're almost there, just I don't want to become draggy. So we proceed to the third chapter. So now we proceed to the next chapter, chapter 3, questions 34D. Histronikotoxin. This is a toxin found in the skin of poison frog from South Africa. So when it comes to these questions to identify functional group, first focus on the multiple bond first. Like for example, in this case, we just identify which is the alkyne groups, then next alkene groups, and next amine groups, and the last one alcohol, secondary alcohol. It's pretty straightforward, huh? So next is the penicillin G. This is an antibiotic used to treat numbers of bacterial infections. So it seems like more complicated. No worry. We just proceed to the first step, multiple bonds. So we just identify the aromatic rings. So next, there's a confusion there between the NH and double bond O. So first, we just identify the N first, the N atom. So for the left side, nitrogen is a secondary amine for the meanwhile. So the right side is a tertiary amine. So since there's an adjacent C double bond O there, so it is a secondary amide and the tertiary amide. So the rest just pretty straightforward. Sulfide group and the carboxylic acid group. Next is the salinosporamide A. This is a potent proteasome inhibitor being studied as a potential anti-cancer agent. So in this case, first of all, find the multiple bond, which is alkane. After that, identify the primary alkyl halides and the quite obvious one, secondary alcohols. So here's some confusions in these structures. So we just focus on the right side, the NH and the C double bond O. Obviously, there's a amides, which is a secondary amide, while the left side double bond O, because the adjacent is the ether. So the combination of it is the ester group. Next. So this is a indinavir. This is the drugs to treat HIV and AIDS. So the first question is, at which site can indinavir hydrogen bond to another molecule like itself? So to do so, a compound need an OH or NH bond. So the first question is in the blue circles, where the site, the functional group of NH or OH. Can the indinavir form hydrogen bond to another molecule like itself? So for second questions, which site can undeniable hydrogens bond to water? So as long as the compound got O or N atoms, it can be formed hydrogen bonds to water, which is the yellow circle parts. Next, chapter 3, questions 43a. When the compounds in each group in orders of increasing boiling point. So for boiling point, the stronger the intermolecular forces, the higher the boiling point. So there's three layers. One, hydrogen bonding. Two, dipole-dipole interaction. And the third, the weakest force, van der Waals force. For in this case, because there's no NH or OH functional group, there's no electronegativity highest atoms, just CH bond. So we do the comparison with van der Waals force, which is we'll find out whether which one has a higher or larger subsurface area, which contribute the physical property with the higher boiling point. So more compact or branches, the less surface area, the lower boiling point. In this case, the most obvious one, structure C, the most branches and more compact. So the least compact one, the less compact is structure B, followed by D, and last A. So A will have the highest boiling point among these structures. So the order will be C, B, D, A. Pretty straightforward. Next, 43b. See, this more complicated, so we follow by the three factors that contribute to the intermolecular forces. So first, hydrogen bonding. So we can see from E, F, G, H, only E have the NH bond. So NH bond contribute highest in the intermolecular forces, make it has the highest boiling point among others. Next, we see the dipole-dipole interaction. It will be the G structures. So after we select all the main two factors, the last van der Waals forces, H and F. Since H got the largest surface area, it got the highest boiling point, and the least boiling point will be structure F. So the order will be F, H, G, E. Next is questions 48. Rank the following compound in order of increasing water solubility. So for water soluble compound, it's either ionic or it's got functional group with an O or N atom that can hydrogen bond to water for every 5 carbon. So in this case, you can see structure A, there's O and H to form hydrogen bond with water molecule. B got two set of O and H to form hydrogen bond. C just only have one oxygen atom to form hydrogen bond, while D has nothing to form hydrogen bond with water molecule. So very obvious, the water solubility order will be D, C, A, B. Next, THC, tetrahydrocannabinol, is the active component in marijuana, and ethanol is the alcohol in alcoholic beverage. Explain why drug screening able to detect the presence of THF but not ethanol weeks after these substances have been introduced into the body. So here's a fact. Water-soluble compound is readily excreted through urine, while the organic solvent-soluble compound will dissolve into fatty tissue and retain for a longer period. So as you can see, THC has relatively more non-polar bonds than polar bonds, make it soluble in organic solvent, which is not very soluble in water, while ethanol has one oxygen atom with two carbons, making it soluble in water. So due to their solubility, THF retain much longer time at fatty tissue, being slowly excreted over the weeks. Hence, drug screening able to detect it, while ethanol is excreted rapidly through urine. So any questions? Please don't ask me through WhatsApp. If can, ask me through Padlets. So I'm using different stuff to play every tutorial, so stay tuned. You see, you must read, and thank you for your attention. Bye.